This video is a biggie, and it's important that we get all these terms on there. And there's 5 different terms on there. So watch this a few times till you get the hang of it. The first thing is a transversal, and I'm not going to write down the definitions. I'm going to read them to you. They are in the book on page 147. If you want to take a picture of that and study them later, but I think if you kind of get an idea of what these things are by looking at their picture, I think it does stick with you pretty well typically. Okay, the first thing is transversal. Transversal is a line that goes through two other lines at different points. That's the book's definition. So right here, I'm going to call this line right here just line T. Okay, and I just remember we could put a little cursive. If you want to make it look cursive, you can. But a little cursive letter we could use just to talk about a line. These two lines I'm going to call line 1 and line 2. Okay, so the transversal is a line that goes through those other two lines in different points. It's also, here's another alternative definition, it's the line that connects vertices of angles. Remember, the vertices are the corners of angles, so remember that. That's the transversal. The first thing is, so I'm going to say my transversal is line T. Okay, the second thing is corresponding angles. Now, I'm going to abbreviate corresponding angles, CA, and I encourage you to do so as well. In fact, I'll have abbreviations for all these other types of special angles that are formed by two lines and a transversal. Corresponding angles are this. They are on the same side of the transversal. One is in the interior of the two lines, one is in the exterior, and they are not a linear pair. Okay, so let's go through a few examples. So corresponding angles. Okay, so I need one in the interior, one in the exterior. I'm going to pick an angle that's in the exterior, just a random angle. How about angle 7 sticks out to me? To get a corresponding angle with angle 7, here's what has to happen. Angle 7 is in the exterior, right? So the other interior, or the other angle has to be in the interior, and it can't be a linear pair with angle 7 or adjacent to it. Okay, so 8 is a linear pair. It's adjacent to angle 7. The one that's in the interior that's not adjacent and on the same side of the transversal is angle 1. So that's an example. I'm going to put in parentheses just to separate them because I want to give a few more. One in the interior, one in the exterior, same side of the transversal, and non-adjacent. Okay, how about this? How about angle 3? Angle 3 is in the exterior, right? I need one on the same side of this transversal, not adjacent to angle 3, and in the interior. Well, that would have to be angle 5. Okay, there is one more. Just as corresponding angles, there's actually a couple more, but let's do one more just to try and get the hang of it. I'm going to pick, how about angle 8? Okay, angle 8, notice, is in the interior of these two angles. This is the interior. I need an angle that's in the exterior on the same side of the transversal and not adjacent. So that would have to be angle 2. There's one more up there. If you want to ask me about in class, I'd be happy to answer. Let's go to the next one. Alternate interior angles. AIs, alternate interior angles. Okay, so they're both in the interior, opposite sides of the transversal. Okay, so how about angle 8? That's in the interior. Now I need one that's on the other side of the transversal, but it can't be a linear pair with it. Other side, so that would be 4. Okay, then there's one more. How about angle 1? Opposite side of the transversal, alternate side of the transversal, not adjacent to it. That would be angle 5. And that's all the alternate interior angles for that picture. There's one more corresponding, but that's all the alternate interiors. Let's do alternate exteriors, AEs. Alternate exterior. Alternate sides of the transversal, both in the exterior. Let's start with angle 7. Okay, it's got to be on the alternate side of that transversal, so it's got to be on the other side, and it's got to be in the exterior. It can't be adjacent, and it's going to be angle 3. How about the other one? Well, that would be angle 2, alternate side of the transversal, in the exterior as well, angle 6. Okay, and the last one, same side interior angles, SSIs. These are tricky. The two trickiest ones for students typically are corresponding same side interior. You can get those, you're going to get this idea. Same side interior angles are on same side of the transversal, and they're both in the interior. Same side of the transversal, both in the interior, angle 8 and angle 1. and then angle 5 and an angle 4. The reason why same side interior angles cause problems is when we make these two lines parallel. Okay, and you saw a little bit of that in the Desmos activity. We're going to talk about that more because special things happen when these two lines are parallel. You still have all these angles, but when these two lines are parallel, special relationships occur. And we're going to talk about that. Oh, today's Wednesday, Thursday, or Friday, maybe even both those days. Thanks.